Hello, my name is Lily. I'm a product manager working on durable functions. In this video, I'm going to demo a simple model evaluation sample implemented using durable functions and a new feature called the durable task scheduler. As you can see in this diagram, the sample will take in a prompt from the user, then cause different language models to get answers to that prompt. The responses are then given to an evaluator model to score based on a certain criteria. We can use durable functions fan-out, fan-in pattern to parallelize the model calls so then the evaluation can be done more efficiently. Let's take a look at the code to see how we can implement a scenario like this. I want to start by looking at the orchestration function. This function defines the steps that will happen for the evaluation. I want to first draw your attention to the list of activity functions here. These functions will make calls to different language models. When I call the task all method passing in the tasks list, durable functions will fan out to these activity functions and run them in parallel. Each of the call activity with retry function takes in as parameters the name of the activity function, the retry option I specified above, and the input to the activity function itself, which are the prompts to the language models in this case. After I get the result from each model, I do some logging. Then I concatenate them to be used in the next activity function, which will do the evaluation. And after that, I do some logging of the final response and return. As you can see, durable functions provides an easy way to implement the parallelization of activity calls. Note that I don't have to worry when my activity is finished. That's taken care of by the framework. I also don't have to worry if any of the activities failed because of transient errors, because of these automatic retries. Furthermore, say this activity for evaluation fails because of errors like networking issues or the VM that's running this app crashes. Durable functions is able to start from the point of failure instead of from the very beginning, so I don't have to get the responses from each model again, which is both time and cost efficient. Now let's take a look at the activity functions. I have one called log that does some simple checks and logs message to a file called mylog.log. And then I have these activity functions that make calls to a specific language model. So for example, the getGPT-5 result activity function will make a call to my GPT-3.5 Turbo model that is deployed to the cloud and return a response. So for each model to be evaluated, I have the corresponding activity function. And then finally, I have this evaluation function. It has a system prompt which tells the model the goal and gives a rubric for evaluating the responses, and then the format for returning the final answer. So this activity function has taken the input from the previous models and adding those to the system prompt here before making the call to GPT-4 to get the evaluation. So now we've taken a look at the orchestrator function and the activity functions. The final component of a durable functions is a client function. Let's take a look at the client function before running this sample. So the client function is what is used to start an instance of the orchestration. Here, the client function is an HTTP trigger. What it will do is it will parse the prompt from the user's HTTP request and pass it to the start new method when the orchestrator function is started. Now let's run the app and make some requests. I'm going to start the virtual environment, and run func-start to start the app. I also have a test.http file here that makes requests, post requests to this localhost endpoint, and this will allow me to test the app very easily. So as you can see, the functions that I have in the app here is listed, and let's make a request. So I'm going to ask what the value proposition of durable functions is and what it's used for. So this actually is the response of the HTTP function. It gives you a list of URLs that you can use to manage the orchestration that is running right now. So for example, get the status, terminate it, but I'm not gonna use these URLs in this demo, so I'm gonna close it. What I wanna show you instead is the output of the mylog.log file. So as you can see, the prompt has been logged and the responses from the different models. So this Phi model is a small language model by Microsoft that has advanced reasoning capabilities in areas like math and science. So now let's look at the evaluation. So based on the GPT-4 model, it looks like Phi-4 is the model that the Phi-4's model's response has the highest score out of all. And these were the criterias and their corresponding scores, and a brief explanation of why. So now let's do another one, just because it's fun. Let's send another request to ask, why is the sky blue? So as you can see, the prompt is logged, the responses from the models, and now let's wait for the final evaluation. Okay, so here it looks like for this particular prompt, the models that has the best response is GPT-3.5 Turbo for the reasons below. So as you can see, durable functions makes implementing this kind of parallelization pattern very easy. There are other patterns that durable functions is helpful in, such as sequential chaining, which we've actually seen a little bit in this model, and asynchronous HTTP APIs or workflows that need human interactions. To support these kinds of stateful patterns, as well as scenarios that require long-running operations, durable functions require something called the backend provider, where the application state is persisted. This sample is using the latest supported backend called the Durable Task Scheduler, or DTS, as you can see configured in host.json. DTS is an Azure managed backend that comes with a monitoring dashboard, which allows you to easily see the status of an orchestration and other useful data. So let's take a look. So it looks like my last orchestration finished in 14 seconds, and I want to take a look at the input. The input was the prompt, and then the output was just the string returned by the orchestration. If I click into the orchestration ID, I see a more detailed view of what happened in this orchestration. So as you can see, it logged the prompt at the beginning and then ran these 3 activity functions in parallel. And after that, did some logging again, and finally called the evaluator activity function. And just like the orchestrator function, I can see the input and output of the activity functions as well. And as you might have noticed here, there are some operations that you can perform on the top. For example, if, say, my orchestration is running slower than usual, I might want to perform some ad hoc operations like pausing it to see, or suspending it to see what's going on, or I might even terminate it so I can investigate. I can also raise an event because orchestrations can wait and respond for external events. I can raise an event here to test my orchestration. Or if, say, there's a service that is supposed to send an event to my orchestration, but it didn't for some reason, I can manually raise an event here. The idea is you can perform these ad hoc operations easily on the dashboard for your orchestrations. Now, this is the end of the demo. You can check out the code on GitHub. As you notice, the sample was written in Python, but Durable Function supports other popular programming languages as well, like .NET, JavaScript, Java, and PowerShell. So be sure to check that out. Thank you.